Here I have two resistors, RA and RB. Let's first check what's the resistance of these two resistors. Put it here and the common. Okay. Lower, increase the sensitivity. Okay. So this is about 21.8 ohms. RB, common for resistance. .8 ohms. So we know RA, the nominal value is 22 ohms, but what we measured is 21.8 ohms. RB, the nominal value is 10 ohms, and we measured it is actually 9.8 ohms. Now we have two resistors. I want to make a potential divider. A potential divider is actually a series circuit. Now we have a power source here. I put the positive here. And I try to make this one vertical, but it doesn't matter. You can put it or horizontal or vertical. It just try to make it see a little bit easier. Okay? So this is the first RA. Now I will connect the RA in series of RB. And then connect RB back to the negative or 0 volt. Okay, now I want to turn on the power source. So I set the power 5 volt and the maximum current it can give is 0.2 ampere. So this is 4.99 according to the meter. I check the current. The current coming out from the meter is 156 milliamp. First, I want to measure the voltage across the RA, the first resistor. So I put it common, and this is for voltage measurement. I turn the multimeter into a voltmeter. I know the maximum voltage here is 5 volts, so I use 20. So this is good enough, and this is for DC voltage. I also expect when the current flow here, this is a high voltage, this is lower, and this is 0 volt. So if I want to measure the potential difference across RA, I put the common here. And I want to measure how much this point is higher with respect to the common. And this is 3.42 volts. Now, I want to measure the voltage across RB. I expect this is 0, so I put the common here and measure the voltage at this point. And this is 1.54. So you can see the sum of the voltage of across RA and across RB is equal to 4.99 or roughly equal to 5. Now, I want to measure the current passing through here. We know this is a series circuit, so the current at each point must be the same. So I will use this point here. I identify this is the point I want to measure the current. So I disconnect this one. Use water analogy. If this is water, I plug this plug into this one. So the current here passing through to the meter, it comes back out from the common and then return back to the point where I just disconnected. I want to measure current, so I will choose the selector, turn it to the MA range. This is what I expect. And this current should be the same current we just read from the current meter of the power supply. So let's look at it. Now the multimeter read 149.5, and if you check the meter, the reading from the power source is 149, so it's really the same. So the basic idea of a potential divider is it divides the 5 volt from here, 5, 0, and divide into the middle point. For example, in some circuits, we cannot use 5 volt for the next stage. So instead, we do the calculation and we hopefully get this voltage, fit this voltage to the next stage of the circuit. So I just verify again what voltage we got from this combination. (20) common voltage. This is 1.54. So at this stage, I can get 1.54 volt for the next stage. Now, the issue is what it means next stage. The next stage itself, it could be anything. So in electronics, we use the idea called RL, R load. It means we represent next stage as a resistor. For example, next stage is a light bulb. So what we're going to say is, I want to get 1.54 volt from here, fit into the light bulb. Now this sounds good because this is what we get, 0, 1.54, and 5 volt. So if I connect this one in parallel, just like this, I will expect I will get 1.54. Okay, make sense? However, it's not so simple because this one, it is a resistor itself. Because if you look at any light bulb, this light bulb has a tungsten filament, and the tungsten filament, it has its own resistance. We can verify this one here. Okay, we get about 2.4 ohm, so it's very low, the resistance, 2.4, 2.3 ohms. So this is the resistance of this filament. Now, another thing is, if we connect this one to here, it means the light bulb. What we are doing is, we effectively make this one parallel. To illustrate this one, I will replace this one by another resistor. And this resistor here is 3.3 ohm. Now, this type of resistor, we call the high power resistor. So this is 3.3 ohms, okay? Exactly as stated here. Now I want to connect this one in parallel to this one. Remember the design of this one is I try to get 1.54 volt across this one. So I will get this one. So imagine this resistor represents the next stage. It can be any complicated circuit, but we can represent the next stage by resistor. So hopefully I will get 1.54. So now turn this one to 20. Common here. So let's see. Now remember these two resistors, now they are connected in parallel. So I can connect this point or this point, they share the same voltage. So I connect here and I connect my meter at this point. Turn it on. Now I get 0.49 volt. Remember, we want to get 1.54, and this is what we measured before we connect this resistor in parallel with RB. However, once we connect this one, it becomes 0.49 volt. Why we are not getting 1.54? And I want to think about it. Now, one thing I can do is I can verify if I disconnect the resistor from here. Now I get 1.54 volt. So we have an issue here. We want to get 1.54 for next stage. And if assume the internal resistance of the next stage is 3.3 ohm. Now I connect the next stage and hopefully get 1.54. Now what I get is 0.49. It's not 1.54. So I'm not getting what I want.